Okay, welcome everyone. Let's make a start. My name's David Haikney. I'm the Director of Engineering for Couchbase over in Europe, based in Manchester in the UK. And this talk is all about the workload that we see. So those of you that caught the keynote yesterday will heard a lot of talk about the digital economy and all of the various different industries inside the digital economy. This talk focuses on a specific phenomenon that's generated by having these digital economy businesses, and that's the ability for peaks of traffic that have been unprecedented. Now that we have more people online more often with more devices, it creates the ability for the amount of traffic coming to your site, your application, your infrastructure to dwarf and be very sort of unpredictable and unstable. So this talk is all about how you can best prepare your infrastructure and your business for when these peaks come. I'll start with a very quick video. So does anyone recognize this footage? Anyone know where this takes place? New York City. So this kind of sort of zombie stampede was earlier in the year in Central Park in New York, and you're absolutely correct that all of the people that are sort of wandering towards something are hunting for Pokemon. Now, for a bonus point, do you know precisely which type of Pokemon they were after? A Vaporeon. Look at this. Give that. Well done. So yes, if you know what a Vaporeon is, congratulations. If you've no idea what I'm talking about, well done to you as well. We'll explain it. So, and this is a nice sort of physical example of what happens when the digital economy and the real world collide. You get these incredible sort of peaks, like Pokemon as a game went just ridiculously viral, the most downloaded game that the world has ever seen. And that's what this talk is about. How does your infrastructure plan and cope with that level of demand? And it's not just about applications, it's not just about Pokemon. Let's look at some other examples here. So we have a Pokemon enthusiast in the room. Anyone watch Game of Thrones? Yep, a few of us. Fantastic series. So this is particularly for the broadcasters. So you'll hear a great talk later on today from one of the major broadcasters in the UK, from Sky Television, of how events like the new series of Game of Thrones or the season finale of Game of Thrones, again, creates this sharp uptake in demand that's placed upon their service and their infrastructure. Not just Game of Thrones, but major sporting events like the Super Bowl here in the US. The number of live streams of that event, again, dwarfs what the regular traffic. Another peak that is created by the digital economy. A favourite example of mine from the UK is the Grand National. So I don't do much betting on horse racing, but there is one horse race a year where I even allow my 4-year-old daughter to place a bet on. So this is like, there's one weekend early in April in the UK where it's the biggest horse race, and for about sort of 40 minutes, about 50 horses tear around this track. And everyone likes to have a little pick, like which one's wearing the favourite colours, which one's got the funniest name. And so again, for online bookmakers, this weekend in early April is their Christmas Day, it's their Black Friday. It's the time of year when they absolutely need their infrastructure to hold its own. And not just for taking business, but obviously there are a lot of browsers as well, people wanting to look up the odds, look at the names of the horses, and so on. So again, something that many people will be completely oblivious to, but if you're an online bookmaker in the UK, you know all about this one particular weekend. A very quick aside that's got nothing to do with this talk whatsoever, but I did have the unfortunate circumstance of my daughter was in school the following week, and she was drawing a picture of a horse, and the teacher comes up to her and says, "Oh, that's a nice horse. What's its name?" And instead of, like, I don't know, Fairy Star or something, she goes, "Shut the front door. It came second in the national." So it's going to make for an awkward parents' evening when I'm encouraging my daughter to gamble. So aside from sports betting, the travel industry. So you'll hear that, again, there's another talk today from one of our good friends at Amadeus, and they have these incredible peaks throughout the year. The Easter holiday, there's a tremendous peak in Easter, over the Easter holiday period for booking travel. A lot of airlines will do sales and flash sales where, again, they're generating tremendous amounts of demand, coinciding with their marketing, their advertising campaigns. And of course, if you're making a big public splash and driving traffic to your website, your application, you need infrastructure that's going to be able to keep up. Let's get a little romantic now. Valentine's Day, 14th of February. So for some companies, again, this is Valentine's Day is their Black Friday. It's the biggest event of the year. So relationship sites, you sort of the Match.coms of the world, they'll do special promotions specifically around this period, and so their traffic throughout the year will be up and down. But there is one huge mountain of traffic around the 14th of February. What could be more exciting than romance? Tax. So again, from the UK, the deadline for online tax submissions is the 31st of January. So when do most of the UK citizens choose to submit their online tax returns? In the week building up. So if you're in the business of assisting the creation of these tax returns, of processing these tax returns, again, you'll see a sharp volume of traffic right at the end. And then there's retail itself, so which has many periods throughout the year. In particular, Black Friday, this relatively recent phenomenon of the day after Thanksgiving, where retailers go bananas with the sales. It's for a few years now, it's been a huge deal in the US. It's made its way to Europe. UK is not immune to Black Friday, even though Thanksgiving's got nothing to do with us whatsoever. We still understand when Thanksgiving is, because Black Friday follows the very next day. Although I understand that recently Black Friday is actually, due to the competitive nature, it moved forward into Thursday, and so Thanksgiving Thursday has become the new Black Friday. But now I've also heard that there's a pushback, and people actually want Thanksgiving Thursday to be Thanksgiving Thursday. So now Black Friday is the new Thanksgiving Thursday Black Friday. So it all swings and roundabouts. And Christmas Day as well. Christmas Day is another good example where everyone will open the new iPhone, the new or the exploding variety, and log on and download apps. And so if you're in providing these the app stores or the logins for these services, Christmas Day, when everyone's unbundling the presents and logging on for the very first time, you see a whole ton of new users coming. So Christmas Day and Black Friday are very important peaks for a lot of our retail and gaming customers. So hopefully this gives you an impression that across the digital economy, throughout, regardless of what industry you're in, parts of your business will be subjected to these quite considerable peaks throughout the course of the year. And Couchbase as an organization, as a technology, are ready-made to cope with this. It's what we do. So before talking a little bit, I'm going to talk a little about what to do, how to prepare for these events, how the technology fits and helps. Let's take a very quick look at what happens if you're not prepared. So this is a real screenshot taken from a UK electronics retailer in 2014, so 2 years ago. Excuse me. And you'll see here that on Black Friday, basically this is what happens when your infrastructure is not ready to cope with that demand. So people wanted to come and browse the bargains and all of the sales, the discounts that are available on the sites. We're given this message here. If you don't mind queuing for 9.5 minutes, we'll be right with you. Now, I hope this doesn't sound too boastful, but I'm British. I'm an expert at queuing. We get taught it at school. But nevertheless, like in 2014, approaching a website and saying 9.5 minutes and we'll be right with you, it's crazy. And who in the right mind is actually going to sit there going, okay, any minute now, things are going to open up. Excuse me, of course not. So of course you're not going to wait. You're going to browse the competitors. You're going to look for your bargains elsewhere. Maybe you'll come back, but chances are that you won't. And so this is exactly the problem that we're trying to avoid. This is the situation that we don't want to be in. You might have seen a number of slides like this. Those of you that rather enjoyed the keynote demo yesterday, where we've got clusters with running hundreds of thousands or millions of operations a second, scaling up to hundreds of nodes with billions of documents and on terabytes of data. This is what Couchbase does. These peaks of traffic, the volume that we can cope with. We've always, from day one, had performance and scalability built as cornerstones of the product, as cornerstones of the architecture. The technology is ready-made for it. My personal responsibility is for the data service, the key value engine. Again, they say you're not supposed to have favorite children, but I do, and it's the data service within Couchbase that's my favorite. So we're particularly proud that even though we've always championed our performance and scalability, in the very recent 4.5 release, we actually managed to increase the throughput on a set of hardware by 25%. So not only are we believe we have the industry-leading performance, we're certainly not resting on our laurels, and we continue to invest quite a lot of time and energy into improving it and advancing it. So I'll show you a little while a demonstration of Couchbase under duress and under load and what happens. But next, like how do you prepare? How do you get yourself ready for one of these peaks that are coming? And it's a bit of a cliche, but I stand by it. It's a true one. That I would use the example of the theatre. So before opening night, what does every single theatre production around the world do on the day previously? They do a dress rehearsal. They run through the entirety of that production, start to finish, to make sure it all goes off without a hitch, so that when opening night comes, they're not doing it for the first time. They've done it once already, and they kind of know what to expect and what to happen. And this is our sort of general advice for preparing for these big events. To simulate it, to go through the motions of what does it mean to be, you don't want when you're at your busiest time of year, your busiest period, when you're under the heaviest volume of traffic, do you really want your infrastructure to be undergoing that for the first time? And so what we do quite often is we work with our customers in order to, how do you get yourself ready? How do you prepare? And this is an oversimplification, but we say there are two facets to it. First of all, get your infrastructure ready. Have some infrastructure that is going to represent your production cluster when the time is right. Now, this isn't always easy. It can often be very difficult to bend arms and twist people so that they'll come up with the hardware. We have people borrowing and stealing sort of development and test hardware. Maybe you're in the fortunate position. A lot of customers have a pre-production cluster that's an exact mirror of the production infrastructure. But again, to as large an extent as possible, we would encourage you to try and come up with something that represents the production infrastructure that you're going to be running on. Probably about 50% of our customers run in a virtualized environment, either their own private virtualization cloud or using one of the public providers like Amazon's EC2 or Google's Compute or Microsoft Azure. And so one of the very compelling reasons for using public services like this is they can do exactly this in a matter of seconds. You can spin up a cluster of 50 nodes in a matter of 5 minutes. And so if hardware is an excuse, if cloud is available to you, then it's certainly an option worth pursuing. And then there's the load. Then there's simulating the level of traffic. So presume you'll make some projection of, okay, if it's a website, we expect this proportion of users, they're going to browse this many pages. That means this many clicks, this many logons, this many accesses to the database itself. And so hopefully you have some way of simulating that level of traffic. Again, it's not easy. It doesn't come for free. Some effort is required up front to build that infrastructure that will allow you to generate your load, to simulate those users. Now, at our layer, where Couchbase is concerned, we're simple folk. We don't know anything about visitors to a website or clicks or tracks. All we see is documents being updated in the data service. We see queries being run. We see indexes. We see full text searches being conducted, etc. And so when we're involved in generating the load, that's the piece that we're interested in. Okay, how big is your data set? What are the size of your documents? How many reads, how many writes do you expect to be doing? What's your working set? How much memory are you going to have available to this? And so in the absence of your own load generator, one of the areas that Couchbase can help with is generating this database level traffic, the reads and writes, the operations. And let me give you a quick example. Again, I'm going to focus on the data service, but the same applies if you're running queries. We have a query load generator. So my favorite weapon of choice is this tool here, which I'm about to demonstrate, CBC Pillow Fight. So this comes installed with our C library SDK, libcouchbase. So if you're on a Linux system, it's a couple of commands to download and install libcouchbase. And Pillow Fight is a magnificent beast. It's got the capability to basically unleash merry hell on your cluster with a few simple commands. It's an absolute animal. So let's take a look. Let's have a look at the animal in practice. So I have, excuse me, a cluster here with. Let me just flip out of that. 1 second. Okay, so here I have my cluster. It's got 3 data service nodes, and it's these nodes. This represents my production cluster, and it's these 3 data service nodes that I'm going to generate this load on. I have 2 terminals open here. So the black one on the right-hand side represents the server itself, and the pale one here on the left-hand side, this is my client. This is where I'm going to run. This is where I'm going to generate my load and run some traffic. So CBC Pillow Fight. If I just show you the help text briefly, it has all of these options that I just described. You can say, okay, how many threads of execution do you want to run? How many documents do you want to operate on? How big do you want those documents to be? What's the read and write ratio of the traffic that you want to perform? So again, it's not perfect. It won't exactly simulate your users clicking around your website, buying products, etc. But if you can make the connection between that and the level of traffic that you expect to see on the database, Pillow Fight is an excellent tool for synthesizing that traffic. So let's look at this in practice. So I have a command here, pre-canned if you like. And let's walk you through the options. So invoking Pillow Fight, pointing it at this cluster, my server node. It's the Connect 2016 bucket. And I'm going to start very simply. I'm going to start with a single thread. I have a minimum and maximum, a minimum size of 256 bytes, a maximum size of 1K. I'm going to batch them into multiple writes, so firing 10 writes at a time, 50-50 read-write, and I'm going to rate limit to 100 operations a second. And so off it pops. So if I flip back to the cluster, if I look at that data bucket, hopefully. Yay, there we go, 100 operations a second. You see my CPU is at 3% performance. You may think, oh, hold on, I thought you were talking about this beast that was going to unleash merry hell, and now you're throwing 100 operations at it. Well, so that's the starting point. So at this point, you're in the game. You've got some load that's generated and running against your cluster. And now comes the interesting part. Now let's start ramping it up. Let's see what how we can put it through its paces. So while we're doing this, one of the things that we like to keep an eye on is how the server itself is standing up and behaving. So if you look at the server, you can look at all of the processes that are running as part of Couchbase. And so we have, if you recall, we've got all of these different services running. These boil down to a number of different processes. The Beam process, that's the cluster manager. That's the one running behind the scenes. We've got babysitters and supervisors. We've got an XDCR process here. The one I'm particularly interested in, the one that's responsible for the data service, is the memcached process. So what we can do is, if we take a look at that process in particular, using the standard Linux top command, we can look and see what each of those threads within that process are doing. And so here we've given each of the threads a name. So this was, I think, introduced in 4.1. So if you explore the threads running in the memcached process, excuse me, swallowed a mouse. You'll see what each of those are up to. And so when you're running as we start to increase the traffic, you'll be able to keep an eye on this and see, look out for any bottlenecks, any of these processes, any of these threads that are running a little hot. Okay, so let's see if we can unleash a bit more of an animal. So let's go up to 1,000 operations, and maybe let's have 2 threads. Flip back to the cluster. So that's 2 threads doing 1,000 operations a second each. Okay, my CPU's gone up to sort of 10, 15%. So again, if this is your projected workload, you'd maybe feel pretty happy about yourself at that moment, going, okay, if I'm going to see sort of 2,000 operations a second, then there you've sort of demonstrated to yourself that your infrastructure is capable of sustaining that level of demand. But we can go further. Let's crank it right up. Let's say 16 threads, and so 10,000. See what happens. Okay. So now you'll notice that the CPU on the node has gone right up. So at least we're starting to make this cluster work. And again, this is one client. This is the beauty of Pillow Fight. That's one client with a relatively few cores that's just like acting as a complete fire hose that's just throwing these operations at this cluster. So very cheap and very quick and easy to be able to simulate this level of traffic. And you can see that clearly, even though we've got, what did I have there? 16 threads trying to do 10,000 operations a second, so 160,000 operations in total that Pillow Fight is trying to throw. You can see that the cluster, these 3 data nodes, are roughly comfortable doing 100,000 in this particular setup, this particular hardware configuration that I've got. So then we start to see an upper limit, and this is very important, of what level of capacity the cluster is capable of. And so again, if we zoom back to the server itself, we say, okay, we have all of these worker threads. Now these worker threads are the ones that sit on the front end and take receipt of the client reads and writes and respond to them. And you can see that many of those threads are running hot, and we'll talk about how to tune some of these later. So hopefully that gives you a quick flavor of how you can very quickly and easily simulate a level of traffic and get a feel for what the upper bounds, what the capabilities of your cluster are. Let me flip back to... Okay, cool. So as part of that, that was the first step along that journey of doing the preparation. So there we took a traffic, we threw some load at it, and we saw roughly here's what the cluster is capable of. But we would also, if you really want to do your due diligence properly, if you really want to best prepare, then don't just plan for the sunny day like that. Don't just go, well, I expected 2,000 operations a second. I could do 2,000 operations a second. Let's leave it there. Go the full distance and actually plan for some of the worst case scenarios. What happens if you underestimate the level of traffic that you're going to see? What is the breaking point of the cluster? How far can you push it before it starts to sort of plateau the number of operations? What happens if a node fails? What happens if your hardware failure on the day? If I went from 3 data nodes down to 2 data nodes, would those 2 data nodes be able to keep up? What would the traffic profile look like? And so do it as part of the dress rehearsal. Kill the nodes, see what happens. Make sure that your application, your infrastructure, Couchbase is equipped to keep up. Even worst case scenarios, what happens if that cluster becomes unavailable? There's a network outage. Do you have a secondary cluster with using XDCR, for example? Can you quickly fail over that cluster? Have you tried and tested that procedure? Does it work? If you needed to restore from backup, when was the last time you took a backup? How long does that backup take to restore, etc.? So actually walking through each of these scenarios will make sure that you're comfortable and you're confident when it comes to the day itself, what the various permutations are should anything happen. And I say pushing the cluster to the breaking point and knowing its limits, particularly for the case where a lot of customers say, I would love to give you the sizing information, the reads and the writes, but our traffic is just that hard to predict. So at least that if you've found the breaking point of your particular cluster and the point at which you would then have to scale up, you can then, when it comes to the day itself, and monitor it, and you would know whether you're within the parameters you've tested or you're on uncharted territory. So that's a little about how the product and the technology holds up. Talk a little bit about Couchbase as an organization. And so we've been helping customers through their peaks. We've been helping, for example, Walmart. Couchbase have been working closely with Walmart ever since Black Friday came into existence, making sure that they had the right infrastructure and the right setup for them to have a successful holiday weekend. And how do we do that? So with our support and professional services organizations, we're very well versed in reviewing clusters and sizing information and putting all the pieces together and saying, have you done the homework that we would expect? So an example of this is with Amadeus, our good friends in Europe, who were planning for one of their peaks. They were migrating a whole heap of traffic to Couchbase. And this is exactly the exercise that we went through them. We did the projections of the workload. We allowed a margin for error. We then advised them on what the cluster size should be. We ran some workload in exactly that same. We used Pillow Fight in exactly the same way that we did there. After the fact, we collected the logs and we checked that had they configured everything, all of the Linux parameters, the swap, the disk tunables in the way that we would advise and recommend as best practice. And then we reviewed the logs from the load generator test itself to see, Could we detect any other bottlenecks, any other possible issues of concern, our write queues, our DCP queues, etc.? Is there anything that we think needs to be tuned or changed? And so it's this level of expertise that the professional services and the support organizations can provide. So if nothing else, just for a second opinion of what to validate what you've seen with your own eyes during your own load test. With the sort of the rise of nickel, what we're seeing more and more is also query optimization. So a lot of people say, okay, my queries are fine, they give me the right results, but actually when I scale up the number of queries I'm doing, I could do with them being a little bit faster. Is there any guidance or advice? And we have, as part of the query language itself, we have the explain command that will tell you which index is being used, and so you can figure out if that's the index you were expecting, etc. But something, again, Couchbase are very, very happy to do is get involved in that discussion with you and that design and saying, okay, what's the intent of the query that you're trying to run? If this was us, here's the sort of index that we would create, here's the way we would structure that query. And often the savings can be reasonably dramatic, taking sort of 100 millisecond response times down to single millisecond response times, etc. Again, so we encourage you to, this is what Couchbase support and professional services are here for. So we encourage you to lean on us, to ask us these questions. Am I best prepared for my big event? Is there a way of optimizing this query? Does my load test look completely healthy to you? We're always happy to get engaged. It's a lot easier for us to get engaged ahead of time when it's all peaceful and that there aren't alarms going off left, right, and center, rather than sort of helping you out. Although we do on occasion do that too. In terms of what happens if you don't run your load test and you think, actually, the cluster as I've stood it up today didn't really meet the requirements that I had. What can I do about it? And so there are some tuning options. The most obvious and the one worth stating and the one we recommend most often is simply capacity. That the majority of problems that you will hit, the majority of limits can be overcome. We have multi-dimensional scaling, so you can scale your query service independently, your indexing independently, your data service independently, etc. So only add what you need. Again, it's easy for us to say, it's not always easy to achieve in practice. Go, okay, you probably need 3 nodes, and customers will say to us, that would be lovely if I had 3 spare bits of hardware. Do you not think if I had 3 spare bits of hardware, they'd be in the cluster already? But again, in the cloud scenario, this is somewhat easy to do. Again, I mentioned tuning the queries. So often there are tweaks and performance advantages to be gained by scrutinizing what your indexes are doing. I showed you some of the threads there as part of the data service, as part of the key value service. So if you notice that some of your one particular group of threads is running at capacity, these are all dynamically scaled based on the hardware that you're running. So Couchbase on a 32-core node will be very different to Couchbase on a 16-core node, for example, in terms of the number of threads. And actually, if we think, well, you're using a lot of DCP replication, you're using indexes, you've got XTCR in the case, you've got 3 buckets, maybe you need to tune some of those. But we'd always advise doing that with the guidance of Couchbase themselves, and promote good science of basically saying don't just tune everything all at once and crank it all up and see what happens. Do the good science of do your benchmark, identify your bottleneck, change one thing, remeasure, notice the difference, and make a determination. Did that help? Did that hinder? Etc. And repeat that exercise. In Couchbase out of the box, it's worth stating, for 95%, probably higher of the use cases, because we scale in accordance with the resources that we're given, the number of threads match the number of CPUs that are available, etc., because we dynamically scale the threads we have internally. More than 95% of the use cases that we see just work out of the box and don't require any of this tuning. And I say it's normally the capacity that we tend to advise on. But sometimes you do need that little bit extra. Okay, a couple of slides now on the big day itself. So you've done your dress rehearsal, you've done your homework, you're feeling pretty good about things, then it's time for opening night, then it's the real crunch. What would we advise to do during that peak? So first thing to do is monitor, to keep an eye on the traffic levels. The first and obvious thing to suggest is at some point you've made an expectation or a projection about how much traffic you're expecting to see. Now, as you monitor the load that's being placed on the cluster, is the load that you're seeing in line with that expectations? Have you missed something somewhere? Is this cluster entering sort of uncharted water in terms of the number of operations? From a client point of view, obviously you're interested in the response time that you're getting for your key value lookups for your queries. So we advise monitoring that at the client side. How long is it taking to get the answers out of Couchbase? Is that steady? Is that rising? Your resources, so looking at the physical hardwares themselves, do you still have sufficient RAM? Do you still have sufficient disk space? I mean, fairly basic stuff. CPUs are an interesting one. You always want a little bit of spare CPU capacity in case you need to add more nodes in. You need to have a little bit left in the tank in case you need to rebalance or something like that. So a rule of thumb there is if you start running, your nodes start running sort of consistently higher than sort of 70 or 80%, that's a good sign that it might be time to introduce some more capacity. I say we give you a ton of stats, and normally people aren't sat there like literally looking at the UI watching these things. These are all available via the command line, via the REST interface, and so they'll pull them out into their own kind of whatever the stats engine that they have. Things like your Nagios, your Cacti, your Stackdriver, etc. Okay. So if something goes wrong, so worst case scenario, and again, touch wood, this hasn't been the case all that often. Again, Couchbase as an organization are here to help you. Our support team offer 3 levels of service level agreement: silver, gold, and platinum. And for our platinum customers, they get, for these P1 production emergencies where either production is down or severely impacted, we guarantee you a 30-minute response time. And that doesn't mean you're going to get an email saying, oh, your call's very important to us. That means you've got an engineer, a highly trained L3 level support engineer on your case, working directly with you in order to get your business back online. I mentioned a 30-minute response time. Two have just walked into the building. That was fantastic timing, Patrick and James. So it's these chaps here that will be taking these calls. That was more 30 seconds than 30 minutes. That was good. Thanks. I'll owe you some money for that. And so normally when in the rare occasions when we get involved, maybe there's already a sort of situation. You have your own conferencing set up, or we'll be happy to initiate that for you. Get on a screen share. We have interactive chat. We have sort of voice conferencing. Whatever it takes to help guide you through whatever repair actions are required, with a laser focus on getting your business back in operation, ensuring business continuity for you. There are some times when root cause analysis can wait, and the most important thing is to make sure that you're serving your traffic to your customers. And so the rewards. So fast forward 12 months from that 2014 scenario, and you have this UK electronics retailer that makes records in the UK financial press for all the right reasons, for having a stunning success on their Black Friday period. And we're happy to say that Dixon's is a customer that we worked very closely with, doing exactly this exercise that I've walked you through here, of doing the projections, sitting with them and doing the projections. What level of load do you expect to see? Let's provision a cluster that matches your production environment. Let's run that level of load against it. We'll walk you through the analysis that we do. And it was actually Patrick in the corner that went and visited this customer in order to be able to do this with them. And obviously the success speaks for itself. So to wrap up, before I open it for questions, again, this is all about the digital economy and its ability to have this phenomenon that regardless of what industry you're in, which vertical you're in, the ability to have these occasional peaks of traffic where the level of volume of interest and activity in your business, your application, your website far outstrips what you tend to see during your normal working period. And Couchbase as an organization have been handling very high-profile customers with very high-profile workloads for a long time now. Both as an organization, as a technology, we're built around being able to support you through this. And if you want the best confidence that your event is going to be successful, doing your preparation, doing the dress rehearsal, so that when it comes to the main event, you'll have a very successful time. With that, thank you very much. Happy to take any questions. Sure.
It's regarding the queues. How the queues are connecting, like the one queue that, is there any dependency on that? The queues are
You mean you mean the internal queues within Couchbase?
Yes.
Okay. So in the data service, the way an operation. So the question was, how are the queues within Couchbase's services connected? And within the data service, when the client sends, let's say the client writes a new document to Couchbase, as soon as that is received in memory, that will be immediately acknowledged back to the client. That's why we can do sort of sub-millisecond response times. As soon as we've got that in memory, we'll say, okay, we've got it. Now, the client can then subsequently ask, I also want you to tell me when it's on disk or when it's been replicated. But that's by default, the client will get receipt immediately. And then what we do is we put that in two separate queues. We put that in a queue ready to be replicated across the network, and then we put that in a queue ready to be synchronized to flush to disk. And so you can see these, actually, if I flip back, I think I still left that workload running. So if we flip back to, if you give me a second, I'll show you what these look like in the user interface itself. Okay. So here you can see the disk write queue, so the number of items that are sat there waiting to be written to disk. And further down, here we have the replication queue. And so what we advise, what we recommend is actually your documents are a lot quicker getting to another node via the network than they often are getting down to disk. So that's the durability that we often advise of. Don't concern yourself too much with how long it takes to get to disk. Concern yourself really with how long it takes to have a second copy on that node. So these both happen asynchronously after it's been written by the application.
Just let me know maybe. So in terms of that, scaling the cluster, how can we look into the queues to see that whether this is some kind of disk kind of issue, latencies, or is it going to be RAM, or is it going to be capacity, or something that maybe you can share?
Yeah, sure. So the question there was how do you, this information is great, but how do you know when it's a problem? How do you know when it's a bottleneck? There's a couple of reasonably easy rules of thumbs that says if it's flat, it's okay. If it's rising, like if your disk write queue or your replication queue is going up and up and up and up, let's say the disk write queue, you see it slowly starting to creep, and you can look over a longer period. So let's say you look at it over let's look at the disk write queue over the. And actually, this isn't too bad an example because it seems to have flattened, but that's something to keep an eye on. So there's an example. If that line just kept on going up and up, you'd say clearly something's wrong here. Clearly, maybe it's the disks underneath. Maybe they're not fast enough to keep up with the level of traffic. Maybe you need more nodes to keep that. So a simple rule of thumb is as long as it's not increasing permanently. Spikes are fine, like going up and then as long as it comes back down, that's absolutely fine. But if it keeps increasing over time. And then the second one I would say is you can always review it as a proportion of the work that you're doing. So imagine you've got a replica configured. So when you write a document, you're going to store it to disk on the primary node. It's going to be replicated and stored to disk on the secondary. So basically for every write the client does, you're going to end up within the cluster with 2 writes down to disk. And so you can see if you're doing 100,000 operations a second and your disk write queue is 50,000 operations a second, then you can see the proportion of the size of the queue compared with the level of traffic that you're doing. And when you factor in the replicas, again, is that reasonable? Is that are those two things roughly equivalent? Or like maybe you've got 5 million items in your disk write queue and you're doing 100,000 operations. You say, hang on, these things are taking an incredibly long time to get to disk. Again, so the magnitude of it is also an indicator. And the precise level that you think that's a concern or not a concern depends on the use case. But again, back to the earlier point, this is exactly why we encourage you to get Couchbase involved, because we will help you be able to do that analysis and make that determination. It's good?
Using the pillow fight, are you responsible for pre-populating a bucket to say million documents, or does it help you pre-populate with some code?
Yeah, that's a great question. So the question was the pillow fight tool. What do you do about populating the data set? And the answer there, the pillow fight does that for you. So you can, if I go back to, you see in the invocation I gave here, each of those threads, before you start running the workload for real, it populates the data set. There's also an argument you can give it that is literally no population. and it'll just get straight to the workload. So you can populate once, and then you can restart and resume the workload as many times as you like. Good. Any other questions? All right. Enjoy the rest of your day. Enjoy the rest of the conference. Cheers.